So three or else more stage comes in the combinational designing. There will be a chance like dynamic hazard may occur. So here, before reaching our original output, it goes on multiple transition. That we already saw, just like this, right? One is our expected output, but we got 0, then 1, then 0, then 1. So important like this. So here also you are going to check how it's occurring. So this is our A B C D. Then I will take this as x1, this as x2, not this is not x2. I will take this as x2, this as x3, this as x4, and this will be our always our output y. So here at the time. Now we are going to see how this dynamic transition occurs, multiple transition occurs in dynamic hazard. So for that particular reason, I am going to consider the input with respect to 1. So in this timing diagram, I will be showing this as 1 and this will be my 0. So first, so I am going to give every input as 1, and I am going to consider the entire circuit as a single delay with 1 nanosecond. So direct output I will try to implement in this area, because when I give the input over here, after 1 second, 1 nanosecond delay only you are going to get the output. So it occurs at time 2, and there I am not going to talk about the stages. So just going to show the output. So in that case, so 1 into 1 is 1 for x1, 1 into 1 is 0 for x2, and 1 into then x3 is x2, which is 0 into 1 is 0 once again, x3, and x4 is the combination of this 0 and this 1, which becomes 1, and 1 into x2 is 0, so your value is 0. So 1 0 0 0 1. So this representation, so see, for this particular input I got this output in each transitions. I didn't consider the delays in each gates. Okay, in this part I directly jumped over here, so leave it. I'm not going to talk about much about it. Now what I'm going to do is I'm going to change this d value to 0. So this will be constant 1, which is C, d will be constant 1, a will be constant 1. Okay, now we can see what is happening. So in the first stage, when 0 changes, b changes to 0, 1 into 0 is 0 for x1, so this becomes 0. 1 into d is 1, b is 0, 1 is 0 0 0, x2 becomes 1. So this part, so which means you can apply directly remaining all condition, it will go. Then come to x3, x2 into c. So x2 is changed here, right? So x3 you should not write here, this should happen here, because this first stage means it's a common time period with respect to t3. Then this is a common time period with respect to t4. This is a common time period with respect to t3, which means the delay is adding in each stages. So so that I should mention my x3 over here. So what is my x3 value is my x2 value 1, and my 1 into 1 is 1, so my x3 value will be 1. So okay, then finally my x4 value is balanced. So x4 is x3, that is 1 into 0, 1 plus 0, that is 1. So my x4 should change here. Okay, here there may be some changes. In this case, if you see, here there may be some changes. So we can see that is x, it is a combination of 1, c and x2, right? C and x2, c and x2, c is 1, this is 0. So here also it will be 0, no issue. Now come to x4. x4 is x3 and x1. To find x4, x3 and x1. So 1 0 1, no issue. Here 0, here also it is 0, so it becomes 0. Okay, now that is done. So some people, what they will do is they will find this part and they will put remaining dashes, so don't do that. So just compare with the transitions, previous transitions, so that you can get some clear idea. Okay, so then finally your output. So now output depends purely on x4 and x2. So x4 and x2, so just apply that. X2 0 1 0 0, then 0 1 0 1 1 1 1 0 0 1 1 1, because this is product. And see, actually when I gave 1 1 1 1 as my previous input, I got the output as 0, no issue. Then when I changed to 0, where b around to 0, actually my output also got changed and it should move to 1 immediately. And it also moved to 1. From 0 it moved to 1 with multiple transition. That is, it first is moved on to 0, then 1, then 0, then finally 1. See, multiple time the transition occurs, as I said previously. So in dynamic hazard, this kind of multiple transition occurs. So it is an important thing to eradicate that. So we can see next how to eradicate it. Okay. So on solving for x3 and x4 with respect to y, you will be getting the kind of equation like this. So please do try to recall once again AC plus B into C dash. So C plus C dash. So this part I already shown in static one hazard. So if equation is like A B dash plus BC. If you add a term like A B dash plus BC plus AC, you can eradicate static one hazard. So in this particular circuit, in this formation, here the hazard occurs. So in this part, if you add AC plus B dash C dash, so instead of CC dash, you can add AB into CD dash. So you can eradicate the hazard. You got the idea, I hope so. So this is how you can eradicate in a simplest manner by understanding static one and static zero hazard. And the static one hazard will occur with respect to A dash. Static 0 will occur with respect to A dash. This is one A plus A dash, and this is a combination of both. So it will occur when you take a dynamic concept. It will occur with respect to A plus A dash, like this, A plus A dash into A or something, A dash plus A. In this kind of combinations it will occur. So once you got a very clear idea about this, just apply this concept over here and you can satisfy, or you can finish the dynamic, you can eliminate the dynamic hazard issues.